In nature, each event is permitted through mathematical laws. We can actually see this with the example of gravitation. What you see on the screen is actually what's happening to our planet with the sun, for example. But this doesn't stop there. Motion can be described with expressions. And the same applies to describe the behavior of that line. Now, do you know what is the common point with all these things I showed you? Well, all these events can be described with equations. And you probably already seen them without knowing. What I actually like about equations is that they describe how some expressions can be linked. For example, in physics we have the speed formula. If you know a bit about physics, you know that speed is equal to distance over time. This is written as v equal to d over t. But we can actually modify that equation and, for example, use it to calculate the distance. And we have d is equal to v times t. And finally, we can also calculate the value of time, which is equal to d over v. This actually shows us the presence of equations inside our world. But most of the time, a part of that equation is blurred. Like, for example, here we have 5x plus 3 equal to 18. Now, one might ask, what is x? And I'll reply that this is a variable. But then we'll have another question. What even is a variable? Well, depending on what you're working on, a variable can be a lot of things. Just to show you, a variable can be different if you're a mathematician, a physicist, or even a programmer. For now, we will focus on the mathematician POV. So, if you're a mathematician, a variable is a symbol that can take any value possible, but that value is unknown. Here, x could be 5, or minus 12.5, or even the number pi. It's like a mask on a value. So here is an expression, 5 times 9 equal to 45. What I could do now is replace a value by a variable. So now we will have 5 times x equal to 45. And the goal when solving an equation is to find the value of x. Talking about the equations, we have two types of them. We have independent and dependent variables. Independent variables are variables that can take any value, literally. They don't depend of anything. Imagine the radius of a circle. It can be anything. It can be 4, 8, and you can basically take anything. In this case, the radius of the circle is an example of independent variable. Next, we have the dependent variables. As it's said, it's a variable that depends on other elements. Let's say S is the length of the side of a square. We know that the area is equal to S squared. We can then say that the area is dependent from the square's side. Thus, the dependent variable here is A. By the way, here the area is equal to 25. Since we now know what a variable is, we can ask ourselves, why do we even use variables? And the answer will be to model all kinds of phenomena and properties. So the example is going to be a bit advanced, but in calculus, we'll take a curve. We'll try to calculate the area under that curve using Riemann sums. However, in physics, variables are a bit different, since they represent real-life values, such as the position of an object. Lastly, we have the informatic POV. So, in computer science, variables are not just numbers. They can actually be a lot of things, such as a text, numbers, true or false statements, float, which are decimal numbers, and also arrays, which are a list of data. In informatics, a text is usually called a string. For example, the name and the color of my character are a string. Also keep in mind that all the information showed about the sigma character are an example of variable in informatics. This means that as a computer scientist, your name will be an example of variable. By the way, I often use variables to code these videos. Now that we understand variables, we can ask ourselves how we can actually work with equations. And this is exactly what we are going to talk about right now. Suppose we have a rectangle. We would like to calculate the perimeter of that rectangle. So the formula is 2 times the length plus 2 times the height. But then we have an unknown variable, which is the height. So how can we get it? We can actually get the height by learning how to solve equations, and we'll start by training with linear equations. Linear expressions are written as y equal to mx plus b. M and b are constants, y and x are variables, x being the independent one. So linear equations are used to describe the behavior of straight lines, and they're usually the easiest, so we'll start by working with them. But then again, one might ask how we can actually solve equations. So to solve equations, we pretty much have to follow some principles. They are pretty easy to understand. Principle number 1, try to separate variables and constants. Principle number 2, if you want to do something to one side, apply the same thing to the other side. So let me explain. Suppose we have that equation x plus 1 equal to 6. We first have to identify the variable, which is x, and we'll try to get it on the left, which is already the case. And then we also have 1, and we'll try to put it on the right side. We want to cancel it, so we'll do minus 1. But to do that, we also have to do minus 1 to the right side. So I will repeat. We want to take off 1, so we'll do minus 1. But to do this, we have to do the same to the right side. So we'll do 6 minus 1 and we get x equal to 5. And if you want to test if your answer is correct, here's how you can do. So you take your original equation, you take x, and you will substitute. Basically we had x plus 1 equal to 6, you replace x with 5, and you see if the equation is correct. The main idea behind equations is that you kind of have to cancel terms in order to nullify them. But equations don't have only addition and subtraction in them, they also have products and divisions. So let's learn how to actually deal with them. So basically, if you have 5 times x equal to 45, you can cancel the 5 by dividing both sides by 5, and then you'll have x equal to 9. As an exercise, let's try to solve this equation, shown down below. Here we have 3 times x plus 1 equal to 10. We try first to cancel the 1. So this gives us 10 minus 1. And then we have 3 times x equal to 9. So we divide both sides to cancel the 3. And this will finally give us x equal to 3. Now let's see how we can actually use equations in real life. Imagine you want to go to the cinema, and the total cost of a ticket can be calculated by this formula, where C is the total cost, P is the price, and N the number of tickets you bought. Knowing that a cinema ticket costs $5 and that you took 2 of them, you'll know that the total cost will be $10. This is obvious. But what about this equation? 20 is equal to 5 times n. By using what we learned, we can actually find the value of n. We simply divide both sides, and this gets us n equal to 4. Here is an exercise for you. Let's say you have bought 5 tickets and the total cost is $20.4. Can you tell me what's the cost of only one ticket? Pause the video and I'll give you the solution. So basically, you divide again both sides by 5, and this gives you 4.08 equal to p. To summarize, here's how we can cancel practically anything. If you want to cancel an addition, use subtraction. If you want to cancel products, you can use divisions. If you want to cancel square roots, you can use the square power. And for later, if you want to cancel some exponents, you can use the logarithm, which we'll talk about much later. Beside equations, we also have inequations that describe values that are not equal. So here are the signs that you must learn. I'll let you pause the video. And there is an actual inequation. Basically, it means that 2x plus 3 is lesser than 9. So it works the same as equations, you just have to cancel out terms. You then divide both sides by 2. And then you'll end up getting x is lesser than 3. So this means the solution, if we are correct, is under 3. Now, notice that we can actually describe the solution using the real line number. Finally, this is the end of this video. I hope you liked it. Don't forget to like and subscribe. And see you next time!